Oh, hi. We're starting a unit on gases, and I'd like to start by telling you about a piece of instrumentation here that's looking rather primitive. We call it a barometer, and it helps us in, well, after calculation, telling us what the pressure is. And the way a barometer operates is that you have a dish filled up with a liquid, and I'll tell you in a moment why mercury is so good to use. We have two elements at room temperature and pressure, which are liquids, mercury and bromine. We use mercury. Mercury is very dense. People would say, wow, I'm holding mercury and it's very heavy. And so that allows us to have mercury in this barometer at what we'll call a reasonable height. To assemble a mercury barometer, you have a glass tube. It's sealed at the top, open on one end, and you evacuate it. And you might think about doing this by taking this glass tube, which looks like a really long, stretched out test tube, putting a vacuum on there, and sucking all the air out that you can, covering it with your thumb, and then, of course, the tissue on your thumb would get sucked up, and you would say, wow, it's got a vacuum, it's sucking on my skin. Well, what will happen is that the mercury will get sucked up, as some people call it, but in actuality, what we say in chemistry is we have an atmospheric pressure, and the pressure is pushing down on the pool of mercury, and the mercury can go up because there are no gas molecules, actually very few gas molecules. We can't make a perfect vacuum, so the mercury goes ahead and rises. I'll put a little arrow showing the mercury going up, and I'll put a squiggly little line here for the level that it is. If you've got some type of weather system coming in and you say, hey, we've got a low pressure system, fewer air molecules hitting the mercury and pushing up on the mercury, low pressure, the mercury would fall, and people say, weather system coming in, a drop in the barometer. If it's a weather system that's moving through and it's high pressure, more pressure down, more mercury and it goes higher. Here's a little barometer I put together years ago. Mercury down here in the little dish, the evacuated tube, and the mercury right now is at a level of about this high. If we were to not use mercury but use another liquid, say alcohol or water, we would have a very, very, very tall barometer. It would not be very practical. In all honesty, this barometer, here it is for instructional purposes, out in the open, it's not in a glass case, is going to be off by a little bit. And the reason is we do not want mercury exposed to our air because it's toxic. We don't want mercury fumes, as small amount as they do, come off and breathe them in. So what we do here is, not the glass plate, there's a hole in the glass plate so that pressure is normalized, but we put some vegetable oil on top of the mercury. It floats and it seals the mercury so that we're not exposed to mercury fumes. I have a meter stick here. Many people would call it a yardstick if it was this long. It's a couple of inches longer, so a meter stick. I'm going to set it up here, and we can measure the mercury. And in fact, it looks like we're looking at 790. Yeah, 790. That looks pretty good. And those would be millimeters of mercury. Let me write that down on the board. 790 millimeters of mercury. And just like they used to do years ago, we can use millimeters of mercury as our units. So this is a barometer. We're telling people it's filled up with mercury, and we're telling people it is 790 millimeters high. Now, some people like using other units for pressure, like torr, PSI, which is pounds per square inch, atmospheres. In this class, we'll commonly use millimeters of mercury because it's real. We can measure it just using a meter stick, and we'll use atmospheres. There's a quick conversion factor, and that is 780 millimeters of mercury is what's known as an atmosphere. 1 atmosphere, we use the abbreviation ATM. I love using the unit of atmosphere because on a standard day, standard being just a typical day, we're at 1 atmosphere. It's like I can go around telling people we live at 1 atmosphere, and that's 780 millimeters of mercury. Here in Oregon, we have very, very stable air. Tornadoes, hurricanes, unheard of. And so we don't have these big weather systems come in, and so our barometers fluctuate very, very small. This is probably, 10 millimeters off. This is probably about the most that would be off. And we did have a little weather system come in and change things last night. So here we are at 790 millimeters of mercury, or a little over 1 atmosphere. Let me follow up about this idea of pressure. We have molecules in the atmosphere. Mostly, these molecules are nitrogen and oxygen molecules, the N2 and the O2 molecules. We're going to talk about those lines and the bonding shortly. But these molecules are put together where we have two nitrogens hooked together. We have two oxygens, so a couple of red spheres for some oxygens here, put together. These are traveling extremely fast through the room. Many of these are striking the mercury and making the mercury go up. Now, a good thing about having a face that's three-dimensional is these are hitting one side and something else, like a little carbon dioxide, is hitting over here. Some nitrogen's hitting you over here. And so you're not feeling the pressure like on one side of your face. You're completely surrounded by this. There's some evidence to show that, and that is a primitive little suction cup. So this is a suction cup. Bought this at a store that installs glass. So they'll stick this onto a piece of glass and be able to carry like a window out of glass. This suction cup will not stick for a long time to the board because the board, to go ahead and hold chalk, has little pores in it, but it works pretty good. You know how to use a suction cup. Go ahead and smash it on there and it sticks. In a moment it'll undo itself. There it goes. Now it's stuck really good to the floor because the floor is really, really smooth. There we go. I can stick it to the table and have problems lifting it up. People know how to get suction cups. You peel them up. The reason a suction cup works is because I'm going to set it gently up against there, it'll fall, but people push. And what you're doing is by pushing on it, you're squeezing the gas out from behind. So there's gases hitting it, but there's no gases coming back the other way. So gases on the outside are holding it. Well, a little bit of gas is getting behind there because of the nooks and crannies in the board, and the suction cup falls. There it is on the floor again.